Screen. Okay, so are we good to go?
Yes.
Okay, so hello everybody. Apologies, I don't know what was going on. I was boasting that Zoom was the only platform I'd never had trouble with, so I can't say that anymore. So thanks so much for being here today. And in this first one of these webinars that POET is sponsoring, we're going to talk about marine renewables and offshore wind, particularly potential effects of offshore energy. What do we know? What don't we know? What are some resources? So we're going to talk about marine renewable energy, I'll call MRE, and then floating offshore wind, or offshore wind in general, OSW. And I want to start by spending some time talking about the similarities and differences among the technologies and their potential effects. Then I want to really focus in on what we know from the marine renewable side and how it's applicable to offshore wind. And then I'll end with providing you some resources which you may or may not be familiar with. At that point, I'm going to hand it over to Ginevra and Alicia to talk about offshore wind synthesis of environmental effects research and some of the work they've been doing looking at international capabilities and knowledge, and also what's going on here in the US. Okay. So first of all, marine renewable energy. This really is defined as capturing energy from the movement of water, waves, tides, ocean currents. It can also include some other mechanisms such as harvesting energy from differentials, temperature differentials, salinity differentials, etc. Most of these devices are deployed fairly near shore. By that, I mean within a few kilometers of shore, or 10 kilometers probably at most. They tend to be not in tremendously deep water, and they all, like offshore wind, have to have some kind of shore-based location where a cable comes ashore. And there's a whole variety of technologies in the MRE space that are undergoing various stages of development and testing, and there are just the beginnings of some commercial arrays of devices. What you're seeing here in the upper right and lower left are two different kinds of tidal turbines. The upper left and lower right are two of the many, many different designs that are being used to harvest waves. If we look at offshore wind, particularly floating offshore wind, of course, in this case, we're capturing energy from the movement of air, offshore winds, and these are generally stronger and more persistent than winds on land. The fixed bottom type, which is you're seeing in the upper right picture there, is the most common of the offshore wind, and those are drilled into the bottom. But of course, that works mostly in fairly shallow water, 30, 40, 45 meters at most. As we get to the deeper water, such as we have in the off the west coast, there's a need to go with a floating platform, and there's a number of designs underway. You can see those along the bottom, various ones on platforms and spars and tension legs and so on. Most of these are in the testing phase. There's a few that have been deployed for a couple of years on sort of extended testing, but the first commercial, if you will, scale array of 5 turbines was deployed in Scotland about 1.5 years ago. So it's still quite a young technology. So what really are similar between marine renewables and offshore wind? And what you have is this, courtesy of our intern, Haley Farr, are these drawings of, these are wave devices on the left, tidal turbines down on the bottom, and then offshore wind, floating offshore wind over on the right. So what's really similar? Well, all of them have to have either mooring lines or foundations. And although we've depicted tidal turbines here as bottom mounted, there are also floating tidal turbines that have mooring lines. There must be, if you have a mooring line, you have to have a way to anchor to the bottom or be sitting on the bottom. There is the potential for having draped electrical cables between wave devices or wind platforms in order to link together the electrical output before taking it to the seafloor and in towards shore. These of course all have to be deployed at sea by some means, usually by vessel, sometimes quite large vessel. There's a surface expression for many of them, particularly wave devices, many wave devices, and obviously wind devices, and a few of the floating tidal as well. And there has to be an export cable, something that takes that energy to shore. In many cases, when you get to larger arrays, there may be an electrical substation as well, where the various cables come together, the electricity may be conditioned, stepped down, et cetera, before being sent to shore. So there's really a lot of similarities there. Oh, and of course, with a surface expression, you must have lighting of some sort. So what's really different between MRE devices and offshore wind? Well, distance from shore is a key one. As I mentioned, most of the MRE devices are within a few kilometers of shore, and the offshore wind, particularly floating offshore wind, is likely to be 10 to 50 or more kilometers offshore. That's where the better winds are. That's where we can really capture energy. So that with that goes, of course, deeper water as you get further offshore, off onto the continental shelf and the slope. The most obvious difference with offshore wind is we have a tower, a rotor, and blades. And then the scale is very different. Most of these MRE devices, even at the large commercial scale, are expected to top out at about 1 megawatt plate. And offshore wind turbines at the moment are running 6, 8, 10, and larger megawatts per tower. Also, while most wave devices are likely to have a single mooring, and the same is true of most floating tidal, in order to keep these larger wind platforms in place, very typically it would be 3 to 4 mooring lines. And of course, the amount of power that's being moved from the wind turbines is greater. Okay, so a lot of what I'm going to talk about here today, I'm deriving from this 2016 State of the Science report. This was developed and published by the International Energy Agency's Ocean Energy Systems. Now, Ocean Energy Systems is a grouping of 25 nations that have an interest in deploying marine renewables, wave, tidal, and so on. And we have a task, we lead a task under this called OES Environmental. And they're the ones, it was formerly known as Annex 4, if that rings any bells. And this report was the culmination of one of the phases of that process. And it summarizes interactions and effects of devices on the marine environment, especially on marine animals, habitats, oceanographic processes. And the point was really to make this useful to researchers, regulators, device and project designers and developers, also for policymakers and other stakeholders. There was a previous smaller report written in 2013, and this really sort of adds to that. So digging into this, from the marine renewable energy point of view, we think of environmental effects as consisting of interactions between stressors and receptors. And stressors are those parts of a device or a system that is likely to put stress or cause injury or potentially death to animals in the marine environment. And the receptors are the animals or the habitats themselves. And over the last 10 years, we've sort of honed these stressors from marine renewable devices down to 7. Risk of collision from running into a turbine blade, risk of underwater noise to animals, risk from electromagnetic fields from cables, changes in habitats due to the operation, changes in oceanographic systems, potential for entanglement or entrapment of animals with mooring lines. And the last one here, displacement, I'm not going to talk about further today, because this really is the idea that if you had many, many devices out in the ocean, you could displace animals, not allow them to get to their preferred habitats, perhaps interrupt migratory pathways. This is completely theoretical at this point because there simply aren't enough devices to look into this. But these other stressors, I'm going to talk about sort of one by one, how they are, what we know about them in the marine renewable space, and how this applies to offshore wind. Starting with collision risk. Here, the concern is you have a turbine rotating blade. This could also be a river turbine, by the way, but it could hurt fish in the river, marine mammals, diving seabirds, even potentially sea turtles in warmer waters. We don't see wave devices as posing much of a risk here because they just don't have submerged moving parts. It's important to know there have never yet been observations of a marine mammal or a diving seabird colliding with a turbine. I have to admit we have limited video, but that library is definitely growing, and it hasn't been observed. Doesn't mean it can't happen. We've seen some observations of fish interacting with turbines, but it's always a little hard to observe exactly, but we don't seem to see harm to those fish. They may appear to get very close to a turbine, then swim off. It's important to note that the technologies we use to observe these collisions are not well developed, and they're really hard to operate in high energy environments. You may have murky water, all kinds of things. So to really try to find a simple way to kind of put forward over time what we think is the potential risk associated with collision of animals, we're using this little colorful odometer you see down on the lower right. You're going to see a number of these. And from a perception point of view, we consider this to still be a pretty high risk, sort of up there in the orange area. And these gray bars on the left are really our way of trying to say, what are the pathways forward to try to better understand and even reduce that risk? We think there has to be really good sharing of the information we already know. But in the case of collisions, we need better modeling of the interactions. The models we're using actually derive from land-based wind and birds, and they're not that good. We don't have the monitoring data to calibrate those models, and there's still research needed to really understand this better, particularly if we're causing behavioral changes. Will the animals then increase their risk of collision or other bad things happening? Okay, so how's this applicable to floating wind? Well, obviously collision risk for floating wind is one of the big concerns, but it's not in water, it's in air because of the turbine blades. And the concerns are really for birds and bats. However, for floating offshore wind, as opposed to some of the bottom-based, most of this is going to be quite far out at sea, which means there are few bats, with the exception of situations where there are islands offshore and the bats are kind of commuting back and forth. But we're generally talking about open ocean seabirds, the big gliders, albatross, shearwaters, etc. It's very difficult to observe these collisions around turbines, though it's not as hard as trying to do it underwater. But of course, we can't fall back on the usual picking up dead carcasses, which is used to estimate collision on land-based wind. So part of the approach here for wind, and this is I think I forgot to say that, but for tidal, it's the same thing. Understanding which species at risk may be in the area and could therefore be harmed. And obviously some species are more equal than others. We tend to concentrate on those that are endangered, threatened, or have depleted populations. So some of the things to think about with seabirds offshore for these floating wind turbines is how far offshore are you? What is the flight height of these animals? Do they stay close to the water and therefore likely below the blade sweep? What are their migratory patterns? And the relative risk of animals being hit by turbine blades on a wind farm, of course, pretty technology specific. How big are the blades? How are they formed? What is their speed? What is their tip ratio, speed ratio? Where are they located? What is the weather? Is it likely to be a time when birds are not able to see the turbines? What is the lighting on the farms, which help to warn birds? And how is the farm laid out? Typically, these floating offshore wind farms, the minimum distance between platforms would be 1/2 to 1 kilometer. So there's a fair amount of space in between them. Okay, that's what we know about collision risk, I think. Let's move to underwater noise. We know animals use sound in the marine environment, much as animals on land and humans use sight, light. They use it for communication, for navigation, finding prey, evading predators, etc. And we know that when we add more sound to the ocean, we can create behavioral changes in animals, and if the sounds are loud enough, actual physical harm. What we have focused on for marine renewables is operational noise, not construction noise, so not pile driving, but rather the rotation noise from the blades, the generators, the power takeoffs, etc. Now, we have a couple of really nice tools in the US. We have US regulatory action thresholds for marine mammal for underwater noise put forward by NOAA, and there is guidance for fish also put forward by BOEM, though it's not yet in regulation. And so we have something to measure against. We also are fortunate to have, that should say IEC actually, the International Electrochemical Commission TC 114. This is a set of techie people from many countries who have come together to create international standards for various aspects of marine renewables. And we have one for measuring underwater sound. So we have a standard way to measure sound and we have something to measure it against. We have measured sound out of a number of wave energy converters, or WECs, and turbines. And to date, they all fall under these thresholds. Now, they haven't all been measured perhaps by international standards, but going forward, that's really the attempt. So with this in mind, we consider this to be quite a bit lower risk than collision, but there's still questions because we haven't measured enough of these devices. Probably the thing we need most is more monitoring data. We can model sound, especially as we move towards arrays, but we need to know that these models are accurate in these high energy environments. So if we move to underwater noise, how this applies to floating wind, we know that there's noise from turbine blades and the generator in the air. It's not usually considered to be excessive, certainly in land-based wind, and likely offshore, because simply the sound of the wind is probably as loud. The few that have been measured in offshore floating turbines, it's been very difficult to hear the sound of the turbine, even at close quarters above the sound of wind and wave. There is concern that vibration from the tower could transmit underwater, but as sort of a rule of thumb, if it is sound in air, about 10% is likely to transmit through water. So it really doesn't seem like sound is likely to be a very big issue for marine mammals or fish around these floating turbines. If you had bottom-based turbines, there is the potential to transmit more vibration into the sediments and so on. But with these floating turbines, that really isn't much of a concern. Okay, thinking about electromagnetic fields, EMFs, what do we know from marine renewables? We know these fields are coming off electrical cables, substations, and that they may affect certain sensitive species. Now, many marine species just don't have the sensory apparatus to detect these fields, but those that do, we've tried to look at. And there's been a whole range of lab and field studies that show some effects. Animals, eels and fish will swim across an energized cable, not necessarily an MRE cable, but an energized cable. They will take note. But so far, there has been no sense that this has created a barrier effect to fish, to crab, to lobster, and so on. And some of the sharks, some of the elasmobranchs, skates, rays, but only certain species are sensitive. Again, they take note, but don't seem to have any bad outcomes from this. However, we have no regulatory action thresholds and no standardized methods for measurement, which makes it a little tougher, which is why what we know is based on research studies and some monitoring. We can, in fact, bury the export cables that are along the seabed. This is not truly a mitigation of the field, but rather separating the animals from the field. So that's quite effective in areas where it becomes important. So overall, for marine renewables, we consider EMF to be a pretty low risk. What we really need to do is make sure that we broadly analyze and share the existing information. We probably need to be able to model this better for different kinds of cables, different AC and DC, different size cables, different twists of cables, and have monitoring data to verify those findings. But we think that we've got a pretty good path forward here. Now, when we move to floating wind, of course, these offshore wind cables will carry much higher capacity power, so that the levels of EMF will be higher. So understanding when there are some of these sensitive species in the area is probably important. Again, the export cables can be buried or covered with mattresses and keeping animals largely from the cable. One of the other issues, of course, is the potential for these draped cables between platforms to be exposing pelagic species. Now, by definition, these cables carry less power than the large export cable that goes to shore. We have done some modeling for this. There is really no measurements because there aren't enough out there. But the modeling appears to show a die-off of these fields to background levels in less than a meter. The ones we looked at off Oregon were died off to background in about ½ meter. But this is probably an area where at least there has to be some examination when large wind farms carrying large amounts of electricity are put in place. Habitat changes. So for marine renewables, you have to put down a foundation, like a tidal turbine sitting on the bottom, an anchor, and then something to keep it in place for a floating system. And then, of course, there's a cable route that runs through the benthic habitat. At the same time, for floating apparatus, you need mooring lines in the water column. So you're changing some habitat both on the benthos and for the pelagic species. This really doesn't differ from anything else we put in the marine environment. Navigation buoys with mooring lines, various telecom cables, development near shore of piers and anchors and foundations and so on. So we can learn an awful lot. Oh, and even offshore oil and gas platforms. We can learn an awful lot from these. And the real issues we know is that, yes, changing habitat can alter species abundance, some patterns of ecological succession. There is a theory that this can provide an opening for non-native species to establish, although we've actually never found any real evidence of that in areas that did not already have non-native species. So with that learning from other industries, this becomes the real estate issue: location, location, location. Siting is most important. If you have a lot of soft bottom habitat, you don't put your marine renewable device on top of the only rocky reef or the only deep water corals or deep water sponges or other habitats that are very slow growing. So it's really a matter of having a good benthic habitat survey and siting appropriately. In addition, as soon as you put something in the marine environment, we know that benthic organisms will land on it and grow, encrusting organisms and others, and certain fish species will come and hang around it by reefing. However, it's difficult, although biofouling may be a problem to the development, the device developers, it really doesn't appear to be any kind of ecological problem. The same with reefing fish. It's really hard to see any potential damage there. So we think of this as really a pretty low risk, and it's mostly a matter of really ensuring that there is a common understanding of what we know from other industries and how it applies to marine renewables. Now, when we look at floating wind, really very similarly, you have anchors, you have cable routes, etc. You have mooring lines for floating devices. Now, these are mostly in deeper water, of course, than the marine renewable energy devices. And as you go away from the coast, the biodiversity drops, the abundance drops. It's not to say that certain species won't be there, but these are not likely to be placed in quite as biodiversity hotspots as the marine renewable energy devices might be. So again, siting properly, not putting your anchors on top of the only reef in sight, not tearing up eelgrass. Well, the eelgrass bed's too deep for that. Really is the answer here. So we think this is very, very, very manageable for floating wind. Okay, oceanographic systems. Now, of course, the physical oceanography is what defines so much of what is habitats, where organisms live, dissolved gases, dissolved nutrients, and so on. And with marine renewables, if you had enough turbines in a place, you could change some natural currents or flow patterns, and even removing energy from the system is likely to do something. Same with wave energy devices. You may change wave heights, and this was a big issue with surfers early on until the theoretical limits were shown to be changes of a few millimeters. The concern here is if you had enough of this going on, though, you could have cascading effects on sediment transport, eventually water quality, and marine food webs. Now, we know that single devices, you put out one turbine or one wave energy converter, you cannot measure the effects. They are way, way smaller than the natural variability. However, if we go to very large arrays, hundreds of devices, if that were to ever occur, this is something that should be measured. At this point, we rely on numerical computer models and analytical tool of choice because we can put in as many realistic devices as we want and work with the natural flow. Hydrodynamic models are really good now, and we can get a very good idea of the number of devices placed in what locations, in what patterns are likely to cause change. And what we're seeing at the moment is that we are talking about hundreds and hundreds of wave or tidal devices unlikely to be permitted under other circumstances. So we see this, especially for small numbers of devices, as a really low risk. So we need to continue to improve upon our models, especially as we go to larger numbers of devices, and we need to share what we know. So what about for floating wind? Well, you would expect a similar effect with floating foundations as you would with surface floating wave energy converters. You might see some small decrease in wave heights just being interrupted, but most likely some interruption of wind-driven waves simply because you have these platforms sitting there. However, they are really put in pretty deep water, so the most likely interaction, if you had really large farms, is perhaps interacting with ocean currents, coastal currents like the California current system, the Davidson current, and so on. But again, we'd need to model this. It hasn't been modeled to date, to my knowledge. I suspect we will find that, again, for reasonable size farms, 20, 40, 50, or whatever platforms, the effects on these currents are likely to be undetectable, but it's something to take into account. These farms are sited with wake effects in mind. You don't put them so close that one turbine, shadows the other, so they are some distance apart as well. Okay, last one I want to talk about, entanglement. This idea that you could entrap or entangle large marine animals, especially migratory whales, in mooring lines. Now, these concerns come from the fact that marine mammals, including large whales, are lost every year to abandoned fishing gear. And once upon a time, when they first started putting submarine cables across the ocean, they were very slack and they had loops. And we know instances where whales were captured and drowned. That practice with submarine cables was stopped close to 100 years ago. So that's really not a concern. Fishing gear continues to be a concern, but we need to think about the fact that it is a loose end or a loop that has to entangle the animal. And the marine renewable energy devices have taut moorings. No one will have a loose enough mooring to entangle an animal. So we think for marine renewable energy, this risk is really, really low. And we need to share the information and perhaps continue to model this kind of interaction. If you think especially about having a single mooring line, it's really quite difficult to envision a scenario where that occurs, where entanglement occurs. Now, if we think about floating wind, many of these devices, of course, will have 3 or 4 mooring lines. So you've got more lines in the water. But they are likely to be sited further offshore. So that means, again, understanding what animals are present. For example, off the West Coast, the gray whales pretty much migrate up and down the West Coast of Washington, Oregon, and California within 5 miles, 8, 9 kilometers of the coastline. And very few floating platforms, if any, would ever be sited that close to shore. So probably the grays are not an issue, but perhaps further offshore, some of the other large migratory whales like humpbacks. This has become a big concern with stakeholders for direct interaction. And it's also raised that the secondary risk of derelict fishing gear getting entangled and then entangling these animals could be a concern as well. That's one that I think is very hard to deal with because it is an interaction of 2 industries and it's a whole sort of causation chain that would have to occur. So just to address this issue, and I'm sure many of you have seen this, and I hope I won't bore you to death with it, we were asked by the Bureau of Ocean Energy Management a couple of years ago to help them with envisioning what this entanglement issue might look like. And I'm going to play this video for you. I hope you don't mind. So we were asked to look at what this could consist of. We picked humpback whales migrating up the US West Coast. We've done the same thing for the whales in Hawaii. We picked a mother and calf as being the largest potential risk because they're sort of the largest cross section as they might come upon a floating wind farm. Okay. I'm hoping that with that video, you get a sense of scale, which is what we were really after there, and the sense that those quite large whales are really pretty unlikely to get entangled or entrapped in those lines. This is going to continue to be a question, but I think that we have some sense of it. Okay, so I want to end up here just having run through all that, a lot of information really quickly, just in case you aren't familiar with a couple of resources here. TETHIS is our online knowledge management system developed and maintained at Pacific Northwest National Lab. It is aimed at using resources to understand environmental effects of marine energy and also wind energy. There's over 6,000 scientific papers, reports, and other documents, which you can search either by a knowledge base, think of like a database, you can filter and keyword search. It's also visible on a map viewer, which is a geographic look at where these studies and projects and so on are located. Lots of other resources on TETHIS. If you go and look, we've archived a whole series of webinars. TETHIS Blast is our bi-weekly email newsletter, if you will, telling you about news and events, but also new entries on TETHIS. And if you're interested, you just have to go to TETHIS and sign up, and lots of other things there as well. So I'd really encourage you to do that. And you'll see that on this front page of TETHIS, in addition to marine energy and wind energy, we also have a couple of other programs, notably in the lower left, OES Environmental, which I've been really drawing that material from. OES Environmental, as I said, formerly NX4, started in 2010. We've been through 3 phases. The end of the first phase was that first report in 2013. End of second phase, the 2016 report that I've really been drawing information from today. And we are just finishing up, as of May next month, the third phase. And we will have a new State of the Science report out. It was supposed to be released at a conference in May. We're still looking at when that'll be, how that'll be done. And we have applied and are likely to be granted a fourth 4-year phase for NX4. Starting in the first phase, we had about 8 countries involved. This last phase, 15 nations have been active throughout North America, Europe, Africa, Asia, and Australia. And the 2020 State of the Science report, this really does take off from where the 2016 report left off. It summarizes these major stressor receptor interactions, particularly what we've learned in the last 4 years, what research has come out, what with increased deployments of devices, more monitoring. We have a large chapter on environmental monitoring technologies for animals around turbines, because this is this really tricky set of sensors that you need to integrate. There's a number of chapters on management and planning and strategies and measures to help move what we know forward. We had 28 authors total from 4 countries, and it's been out for several rounds of review. With a lot of review, we've actually responded to over 1,900 comments on this. As I said, it's an update, and we hope to release it in late May or early June, and that will be released as a public draft. It'll be all prettied up and so on, but it will be a public draft, so there's opportunity to comment with the final released in the late summer. And so I hope you'll stay tuned for that. And I just want to end by saying I'm the one here talking, but I have a large teams at PNNL in Seattle, in Squim, in Richland, the other 14 nations of the OES environmental countries. None of this could happen without them. We're also very grateful to the U.S. Department of Energy Water Power Technologies Office for strong support, and to the Ocean Energy Systems Committee, who support us financially and spiritually, shall we say. Okay, with that, I want to be done, and I really do want to, give the credit to those not here talking. So with that, I'm going to hand this over to Ginevra to start on the talking wind.
Thank you very much, and hopefully you can hear me. If there's a long silence, I assume someone will let me know. Thank you very much for that link between marine energy to floating offshore wind. I'm going to look at it more from the perspective of what international studies are going on or have gone in the past that we can learn from for offshore wind. And then at the end of that, I will hand over to Alicia, who'll talk specifically about what's known as the SEER project, which is gathering all this information together. So next slide, please. Now, from an international perspective, there are lots of different projects going on. This is a very active area. And the first one I wanted to mention is led out of the UK, which is ORGIP, offshore wind. This is the Offshore Renewables Joint Industry Programme. And they're very active both within the marine energy, as in wave and tidal area, but also within offshore wind, which is led by the Carbon Trust. And they are a partnership between different regulators and offshore wind developers within the UK to better inform consenting authorities and to establish true environmental risk. And their body of work really led on from something that used to be called COWRI, which was the Collaborative Offshore Wind Research into the Environment, which did studies for about 10 years looking at birds, noise, and electromagnetic fields at the start of the offshore wind industry. ORGIP Offshore Wind was formed in 2012 and has funded several different studies, one of which, as he has been mentioned in the chat, which is fantastic, lead on to this. This is the ORGIP Bird Collision Avoidance Study, which looked at various different methods to actually understand how birds interact with offshore wind farms. And they used multiple different techniques to actually monitor the birds. So they used radar, they had observers on turbines using laser rangefinders, and they had combined systems which were cameras and radar systems, which took both daytime and nighttime videos. So they started processing what's happening at night as well. And to date, they've found that there are very few birds there at night, which is good, but at least they've shown the techniques that can be used for this kind of monitoring. In particular, they looked at macro, meso, and micro avoidance. So macro is where the birds start avoiding the wind farm outside the wind farm, and then meso are slight changes within the wind farm, and then micro is when you're very close to the turbine blade itself and you're avoiding it. And the aim of this was really to improve the data that are being used within the models. So this was looking at avoidance probabilities and aspects like that. The other different projects that they've funded have looked into mitigation methods such as acoustic deterrence for various different types of marine mammal. So it wasn't looking at the effect of the noise itself, but how they could use different deterrents. And when their focus for this was to use the deterrents during the piling phase, but this could be applied to other periods as well when we would want marine mammals to avoid a specific area. And this focused on porpoise and dolphins primarily, but their techniques and the way they were tagging different mammals to look at how effective these different deterrents were, something we can learn from afterwards. And then another project that they really looked at was the effect on fish spawning grounds. Again, they were looking primarily for piling noise affecting fish that couldn't move out of the area. So not necessarily as applicable, but again, it's a good way of learning about the various different monitoring techniques. Now that was all in their stage one. They kicked off stage two of their offshore wind projects in late 2019. Again, trying to reduce environmental risk and improve the consenting or permitting process that developers have to go through, and increasing that knowledge with regulators and permitting agencies to make sure that things are really understood properly and the true risks are focused on. Beyond that, I also mentioned here Wind Europe, which was a position paper written last year, which really focused on how to promote floating offshore wind. Obviously focused on Europe, but there they put forward various different aspects of how to improve policies so that floating offshore wind specifically could get a kickstart and be ready as the price drops. And they have various graphs in there about the rate of cost for offshore wind and how we have to be ready to be able to deploy it when the technology is at its sweet spot. And there's a range of guidance as to how this can be implemented more effectively. Next slide, please.
Uh-oh.
Hopefully.
Oh, there we go.
Yep, excellent. Thank
Okay.
you. Further initiatives, international bodies looking at this, we have the International Council for the Exploration of the Seas, and there are various working groups looking at specific issues. So in particular, there's the working group on offshore wind development and fisheries, for instance, looking at how offshore wind and fisheries as an industry can coexist and potentially benefit from each other and work together to make sure that the various sensitivities are included when siting a wind farm and during the operation phase. But they also have various other working groups that are relevant. You have a working group on marine, benthal and renewable energy developments, a working group on marine renewable energy, and they include offshore wind within the term marine renewable energy. The working group on spatial fisheries data, and they recently had a workshop on unavoidable survey effort reduction, which it has yet to have the report out, but they are actively working on various issues associated with offshore wind development. And then we also have REN working together to resolve environmental effects of wind energy. This is also established by the International Energy Agency, just like OES Environmental. And this is their Task 34, which focuses on the environmental effects of wind. And it covers both land-based wind and offshore wind. There are 12 countries currently involved in REN, but it is led by the US. And again, its primary objective is to facilitate this international collaboration and knowledge sharing so that lessons can be learned from one location and applied elsewhere. The REN products are on Tethys. Tethys is really a great resource for finding out this information, and they have had various white papers to date, including one on adaptive management and various short science summaries informing various different aspects. And there is one also on harbour porpoises and offshore wind energy. And there are more studies and white papers coming out as that project develops. For various literature and other reports that have come out, in 2019, Martin Perrow was the editor for the Wildlife and Wind Farms Conflicts and Solutions series of books. Now, volumes 1 and 2 focus on onshore wind, but volumes 3 and 4 focus on offshore wind. Volume 3 looks at the potential effects, and volume 4 focuses on various different monitoring and mitigation techniques. And these are really another view of the state of the science where different opinions are on different effects and how we can monitor and mitigate this, learning from what we've known to date. There's also a broad wind energy, the facts, that looks at the industry as a whole and tries to dispel various myths about things. So trying to increase understanding of what the true issues are. And then also a slightly older publication from the Danish offshore wind industry called Key Environmental Issues. This was published about 10 years ago, but summarized data from 2 offshore wind farms, Hornsrev and Nysted, that were collected over 10 years. So it really looked at changes in the habitats, the benthic fauna and flora over time, the distribution of fish and how they reacted to the various scour protection methods and the potential effect of EMF, electromagnetic fields, looked at birds, both migratory birds and birds that used to feed in the area. Then marine mammals, EMF in general, and both sociological and economic factors as well. So it's quite a comprehensive document that's brought this information together, looking at 2 particular locations over a longer time frame, just to see how things have developed. Next slide, please. Moving to the US and various other things that are going on here. NYSERDA, the New York State Energy Research and Development Authority, has been leading a lot of environmental studies looking specifically at New York State, obviously focusing on seabed mounted turbines, and they're proactive at bringing up these various different environmental issues and looking at how we can address these. For instance, they've been involved in looking at marine mammal displacement and effects, and also recently leading workshops on bird collisions and bat collisions, and what we really need to know about both the overall distribution, but how to monitor and effectively assess the data once you've collected it. We then have ROSA, the Responsible Offshore Science Alliance. This grew out of RODA, the Responsible Offshore Development Alliance, which is a coalition of fishing industry associations, and how they can input into offshore wind and other offshore developments, specifically how fishing and offshore wind can coexist, and how knowledge from one can be used in another, and really trying to be a strong and unified voice within the offshore wind development. ROSA itself is looking at the various scientific methods, understanding how fish species are affected, again looking at effective ways of monitoring this to fully understand the potential both from commercially sensitive species but also fish more generally. But their focus is between Maine and North Carolina. So again, different species, and we're talking about on the West Coast, but a lot we can learn from the methods that are employed and the approaches taken to actually doing this monitoring. And then finally on the East Coast, I wanted to mention the Regional Wildlife Science Entity, which is just being stood up now. And this is really to make sure that the environmental understanding is regional rather than just focused on a specific wind farm development. There's been a lot of discussion recently that the true impacts on bird avoidance, for instance, or marine mammal avoidance will go much further than a single wind farm. So the information collected by one developer does not really give us the full picture. And we have to look at the cumulative effect between multiple wind farms and over a larger area. And so building up this regional entity to look at that and to be able to have a more informed opinion about how the study should be run, how data are compared, and looking at it in this larger context is key to fully understanding what's going on. Next slide, please. And then we get to the West Coast, and we have POWER, the Pacific Offshore Wind Energy Research, which Jason knows a lot more about than I do. But this again is really looking at these environmental effects and the environmental context from a regional perspective, so that we can see how changes due to one offshore wind farm could potentially be incorporated into another one, as in either the understanding from one to another, or also potential effects and how we mitigate that. And POWER is at an early stage, but they're going to really look at the research topics and identify what needs looking at, where the understanding is, and support this with true scientific understanding so it's defensible and testable, and then look at what research specific to the West Coast is still needed. And having done that, it then also has a role in communicating this and disseminating the outcomes to others. Next slide, please. SEER that I have mentioned is the US Offshore Wind Synthesis of Environmental Effects Research, and this is funded by the US Department of Energy and is a partnership between PNNL and the National Renewable Energy Laboratory. We are working with entities such as Power and RWSC to ensure that we are sharing information. We have a very similar remit looking at facilitating the transfer of knowledge from all these studies around the world and seeing what is applicable to work within the US. Some of it will be, some of it won't be. And it's how do we apply the knowledge gained over the last couple of decades to this new industry in the US, both on the East Coast and on the West Coast, and how are things changing as we're considering floating offshore wind? What factors are improved, and how do we manage this as we start building different developments? And this in particular, as well as looking at information that is out there, we really want to be able to disseminate this effectively so that there is a common understanding. And as Andrea was mentioning, it's really making sure that we understand the risks so that we focus on those that are really an issue. And for those that are less of an impact, we can manage them at a lower level and therefore move things forward more effectively. I'm now going to hand this over to Alicia to give you more detail about SEER. And Alicia.
Thank you. Thank you. I hope everyone can hear me. So as Ginevra mentioned, this project, the SEER project, will focus on synthesizing and disseminating existing knowledge about environmental effects research. So to that end, one of the major goals of this effort is to succinctly summarize the understanding of environmental effects of offshore wind, including monitoring tools, assessment methods, and mitigation strategies based on existing international research, including perspectives and specifically international expertise. And so in doing that, we will examine which of the state-of-the-art methods and technologies are relevant to environmental issues specific to the US offshore wind industry, and even more so, which methods and technology are relevant specifically to either the US East or West Coast, acknowledging the differences in development environments on each coast. And then ultimately, our efforts aim to identify knowledge and research gaps on the diversity of species, habitat use, and stressors relevant to offshore wind development on both coasts. Also to US environmental, legal, and regulatory structures, and also technological trends and innovations. Next slide, please. Thank you. So ultimately, what will our efforts produce that is relevant to you, to offshore wind stakeholders? So first, our project is going to develop a series of research briefs that review the state of the knowledge on stressor receptor interactions during different phases of offshore wind development, also to provide an evaluation of technical considerations, of monitoring methods and technologies, of mitigation measures, and the hot topic of cumulative impacts. And so the research briefs will serve as kind of a standalone set of documents, but ultimately they'll be collated into a booklet. And in concert with the research briefs, we'll develop a series of research recommendations that summarize information gaps, barriers, and current challenges for both US East and West coasts to inform or guide the future development efforts. And these research recommendations will include priorities and needs of both federal and state agencies, of industry, and specific regions. So hence the real importance here of engaging and collaborating with the East and West Coast regional working groups. We'll engage stakeholders through workshops to socialize and gather feedback from East and West Coast experts, with dedicated workshops on each coast. And as I mentioned, we'll make sure to sync and coordinate with RWSC on the East Coast and Power on the West Coast when priority setting and in establishing research frameworks. And then finally, we'll be disseminating the findings presented in the research briefs and the research recommendations to the broader offshore wind community through a series of webinars and workshops. We anticipate that there'll probably be around 4 webinars on various topics of interest that I'll talk about in a few slides. And during these webinars, we'll invite subject matter experts to present on various topics, and then we'll also have 1 to 2 webinars touching on the research recommendations. Next slide, please. Great, thank you. So as we've talked about, engaging the offshore wind community is a foundational pillar of this project. So to date, our team has engaged a broad range of stakeholders, and just looking at the participant list in this webinar, I see a number of familiar names on there of folks that have participated in previous engagement efforts for SEER. And so during our engagement efforts for the SEER project, we really wanted to gather feedback on a number of topics, including first, quote unquote, hot topics for environmental offshore wind issues. We also wanted to get information on existing international, national, and regional efforts that can be leveraged in concert with our own, and Ginevra talked about many of those. And then we also wanted to gather information on key environmental research gaps on both coasts. And stakeholders were engaged who had expert knowledge on global and US East and West Coast environmental research and considerations, including federal and state agencies, industries, and NGOs and academia. And we engaged stakeholders a number of ways. We started out with a series of one-on-one interviews, either in person at workshops and conferences or via conference call. We also held a series of webinars that were tailored to specific stakeholder groups. And we also distributed an online survey that targeted a broader group of offshore wind stakeholders. Next slide, please. Great, thank you. So one of the main areas of feedback that we were gathering input on was what stakeholders from the various groups thought were the, quote, hot environmental topics of concern related to offshore wind, both on the East and West Coast. And so after compiling all of the results from our various forms of engagement, these 10 categories or common themes rose to the top. And now these topics, as you can see, are very broad categories or themes. Some are stressors, such as noise and EMF, that actually parallel Andrea's commentary on marine renewable energy very well. Others are receptors, such as fish and birds and bats. And some categories are a mix of both, such as concerns related to marine mammals. And then others are even broader and not specific to a stressor or a receptor, such as the interest in environmental monitoring approaches and cumulative effects. And so to help refine our topical focus, our intent is to work with an advisory committee that we're establishing as part of this effort to help us focus and refine this final set of research topics. And so with that said, I'm going to briefly talk through some of the stakeholder concerns that were brought up through our engagement efforts related to each of these topics of interest. And again, many of these will echo what Andrea has already said related to marine renewable energy. So the first one that has a direct parallel to marine renewable energy is noise and acoustic impacts. Here, there was some stakeholder concern and need to explain what noise actually is, given the complexities, and including a definition of baseline noise, such as from vessel traffic versus pile driving and geotechnical surveys. And here, stakeholders identified the need to better understand impacts to marine species as a result of noise. Next, EMF. Again, another parallel to marine renewable energy, here with a focus on populations and migration patterns. Stakeholders here want more clarity on the issues related to EMF, including for species such as flounder, lobster, sharks, and rays. EMF considerations related to cabling are an issue on both coasts, including export and inter-array cables, as well as cables in the water column associated with floating wind with floating wind farms, which obviously would be a concern on the West Coast. Speaking of cables, the next research topic of interest is related to cable considerations in the water column, on the benthos, and on landfall. So here stakeholders are really looking for a better understanding of onshore and nearshore cable connection impacts on sensitive habitat, submerged cable burial impacts, and cabling scenarios and descriptions for floating wind. And for cables in the water column associated with floating wind installations, stakeholders are really looking for more information on entanglement issues, which again is a parallel to marine renewable energy a bit. There are also concerns related to networks of cable in the water column that are connected together, with implications for marine debris to become entangled, leading to potential secondary risks. Next, a hot topic specifically for the West Coast, floating turbine systems and deep water ecosystems. Here, with floating wind being a new technology, there are stakeholder questions about what such wind farm designs could be and what their overall impacts could be on deep water ecosystems. And California stakeholders specifically expressed concern related to the impacts of floating wind on the benthic environment, to whales, to pelagic birds and circulation. And there were also concerns about the effect of large-scale farms on the California current in terms of upwelling and impacts on productivity. So moving now more toward a focus on receptors, one of the receptors of interest is fish, both commercial and non-commercial species, looking at impacts to early life history stages, possible benefits to fish populations, effects on fish migration, on nesting, feeding, and spawning, effects on fish from noise and electromagnetic fields, and habitat and species distribution changes. And just to note, this specific topic of interest really only focuses on environmental effects, and fisheries concerns related to economic impacts and social acceptance are not a focus of our project. The next receptor of concern, birds and bats. Concerns here were expressed related to the potential interactions with wind turbines, both from collisions and also displacement or avoidance. And stakeholders here are really looking for a better understanding of the potential methods for fatality monitoring for birds and bats offshore. Next, one of the largest areas of concern is related to marine mammals, specifically focus on pile driving and noise, very applicable to the East Coast, also vessel strike risk and also entanglement hazards. There was also some concern of operational noise effects for whale migration, and also the need for standardization for monitoring plans in the form of best practices, and database consistency was also stated among stakeholders. And then moving on to benthic habitat disturbance related to scour and anchors. Here, there were just some concerns about scour, anchor scarring, sediment transport, and benthic impacts during construction and long-term operation of wind farms. There was a need to identify the most vulnerable or sensitive benthic communities to offshore wind activities across the entire life cycle of a project, looking at all phases of development. And then there were also questions raised about the use of scour protection and whether it's good to introduce new habitat and the implications of designing for maximum scour. And then moving on to some of these broader categories, there was a lot of interest in kind of the state of the art and what's been done globally related to environmental monitoring technologies, methods, and best practices. So here stakeholders expressed interest for information on monitoring, including first, best practices for pre-construction, construction, and post-construction monitoring, the need for standardization to support the pooling of data and analysis of regional efforts, the state of monitoring technologies for baseline monitoring, for detecting collisions and species identifications and monitoring avoidance or displacement, and then adapting long-standing survey operations and developing new methods that are necessary for monitoring in and around offshore wind farms. And then finally, all of this really leads up to cumulative impacts on vulnerable species and habitat, which we've talked about a little bit, but there's also concern to the cumulative impacts of the aggregation or the dispersal of fish by structures associated with offshore wind and the potential changes to fishing patterns in response to redistribution. And then there's also a need to assess the cumulative impacts in the context of other marine developments as well, including aquaculture, oil and gas, and other factors. Next slide, please. Great, thank you. So what's next for this effort? Well, we've started to engage the East and West Coast entities. On the East Coast, the Regional Wildlife Science Entity, RWSE, and on the West Coast, the Pacific Offshore Wind Energy Research, or POWER. We'll also be engaging subject matter experts to contribute to the research briefs and also reviewers to assist in reviewing the products for this effort. And we really want to work with both RWSE and POWER to co-organize workshops on both the East and West Coast to really look at national and regional priorities and research frameworks. We're also looking at working with RWSE and POWER to contribute to and provide feedback on the research recommendations we develop, specifically what issues and priorities are specific to either the East and West Coast and its respective stakeholders, and then what priorities have both RWSE and POWER identified from their respective regional activities and their efforts that we should make sure that we include in our recommendations moving forward. Finally, we really plan on keeping open lines of communication with both groups, with regular check-ins, and really working with them to understand how our effort can support and contribute to what they, RWSE and POWER, are doing. This is a two-way street, and the last thing that we want to do is to duplicate any effort. So we really want to make sure that all ongoing relevant national and regional efforts are understood and leveraged as appropriate to develop a really comprehensive and robust set of research recommendations that accurately reflect the needs of both the East and West Coast. So with that, I'm going to turn it over to Andrea to provide a summary of what we talked about today.
Thanks, Alicia. Thanks, Ginevra. So you've heard an awful lot. We've talked at you for a very long time, and you've heard a lot of sort of what we think we know about environmental effects, and particularly how they might apply to floating offshore wind. And I think summarizing this is a little difficult, but I do believe that we have extensive environmental knowledge from marine renewable energy, and we also have international perspectives and expertise and experience from offshore wind internationally. And bringing these together to find the commonalities to help identify the existing research gaps really can help to accelerate what we do here on the west coast of the US with floating wind, because there are so many similarities. I think all of us in this field really don't want to see reinventing the wheel every time, but rather be able to add synergistically to what's been done. However, that said, there are some peculiarities associated with floating wind over other bottom-based wind or marine renewables. And like pretty much every part of the ocean, there are species and habitats and interactions, including oceanographic interactions, that are specific to the West Coast. So with a focus on those kinds of investigations, we can probably marry up what we know and take it further. And probably as important as the research we do is ensuring that we do it collaboratively in the US, across sectors, across the research sector, with developers, with regulators, with other stakeholders, but also internationally. I can't stress enough how much we've learned early on in marine renewables from Europe, and now we're in a position to be teaching them a number of things. But we need to do this collaboration, and we need to ensure any information we have is widely disseminated in really accessible manners so that we can help support the development of floating offshore wind, at the same time ensuring we're protecting the marine environment, and also taking into consideration how we support existing users of the ocean. And that's really it. So I'm going to turn this back to Matt. I want to thank, obviously, the speakers here today, and Haley Farr, our intern, who was responsible for putting a lot of this together, and a big thank you to Poet for inviting us to talk with all of you. So back to you, Matt.
Awesome. Thank you, Andrea, Alicia, and Ginevra, very much for your presentation. I'm actually going to pass it over to Jason, who's going to lead some Q&A. We have about 10 minutes for what we scheduled for this. So Jason, take it away. Let me know if you need any help.
All right. Thank you. Hopefully you can hear me here. I'll start by saying that we received a lot of questions, so we're only going to be able to touch on a few of these. So I'm just going to push through, and I'd ask the team to respond sort of in as quick manner as possible so we can touch on as many of these as possible. So first question, we had a lot on acoustics. For example, why limited focus on construction noise for offshore wind? Many farms being built at one time or successfully over many years could be a problem. Isn't that an issue, the cumulative impact?
Do you want me to start with that, Jason?
Sure, Andrea.
Yeah, so good point. This is being looked at really strongly in the southern part of the North Sea, where you've got Belgium and the Netherlands and UK and everybody else putting offshore wind farms in at the same time. That cumulative effects of noise are of concern. The reason that the focus is on construction, pile driving, is because this loud percussive sound is really, really disturbing of marine animals. We know that. There are studies that show that many of them will vacate an area very quickly, although many return, particularly the dolphins and porpoises and so on. And we don't know what the sort of long-term impact on these animals are from having this, cumulative impact of all this sound. If I understood the question correctly, maybe the thought is also, is the cumulative effect of operational noise an issue? We don't know that. We do know individually the turbine noise is not tremendously loud, and there hasn't been much in the way of studies really looking at those kinds of cumulative effects. But certainly it's a big concern for construction, which is why floating, at least in my view, floating wind is really attractive, because you forego that really big stressor.
Andrea, another one for you here says, regarding Andrea's comment on turbines, quote, below NOAA noise thresholds related to NOAA injury criteria based on sound exposure level or NOAA's behavioral disturbance levels, level B, 120 dB, RMS, or both.
We've been looking actually at the new guidelines, the 2016 and 2018 guidelines, which divide them up by the different cetaceans, the sort of the low range, mid range, and high range. And to date, and of course you've got to do a little bit of math, a little bit to get the root mean square of the sound. But of the turbines we've looked at across frequency ranges, because frequency matters as much as amplitude, so far the few that we've measured do not sort of break any of those barriers. And they've been just far enough below that we haven't looked super well at them. If you look at broadband sound, which is what the 120/180 was based on, generally speaking, you stay below those. But the devil, I think, is really in the details. And although those newer standards are frankly really hard to work with, they're a real step towards recognizing that what is likely to disturb a large migratory, humpback or blue whale is very different than what will disturb a dolphin or a porpoise.
Okay.
Does that help?
Sure. And I'm only going to pick a few out of each of these topics so that we can spread it out a little bit. Does anyone study the influence of these technologies on microbes, such as bacterium, and the potential corresponding disruption of the ecological system?
I can take a quick hit at that, and maybe Alicia and Ginevra can follow up on that. This has not really been looked at. There were a few attempts early on to talk about plankton, particularly in things like the Gulf Stream, where it's proposed at some point you may put really huge slow-moving turbines in. And we looked at tidal turbines and things at sort of the small level, like fish larvae and lobster larvae in the Bay of Fundy, and the hydrodynamics are such that they're unlikely to be disturbed. Now, if you really are concerned on the microbial level, it's probably more of a benthic issue. than anything else, because obviously that's where the greatest numbers of these microbial mats and so on are. No one really has. And I would submit that, again, it's really a matter of where you place them. Again, we are discovering more and more there are real microbial, in a positive way, hotspots in the ocean. So we need to avoid those. The other aspect to this is there is a field of study looking at microbes caught in aerosols, sort of basically atmospheric chemistry look. And there has been a few papers talking about could large wind farms, has mostly been on land, disturb some of those atmospheric rivers, and therefore would these microbes caught in aerosols behave differently. But I don't think there's been much done, and I don't think anyone knows what any of that means. Right. Ginevra or Alicia, anything to add there?
I'd agree with you. It was throughout the UK industry, microbes were not looked at as offshore wind was being developed, and where there were sensitive species within the habitat, as you say, it was avoided rather than studied.
Yeah.
Great. So here's another question regarding the benthic environment. Will biomass be considered before and after the construction of these platforms?
This is benthic biomass?
Yes.
There is a baseline, if that's what the question is getting at, as in these things are monitored the area is monitored to make sure we know what is there, what species are there, how much is there, and assess the resiliency of those species. And then it is again monitored afterwards. Whether the actual biomass assessment is done depends on, at the moment, it depends what techniques being used to look at the changes. But yes, there is a before and after measurement done.
And the irony is, at least with bottom-based wind turbines, you get such a huge biomass increase from biofouling organisms on the part of the tower underwater, which is less of an issue, obviously, with the platform. So you may get some on the platform, some on the mooring lines. Biomass itself becomes a little bit of a strange measure, because you may actually see big increases in biomass, but it really depends on what you consider sort of those beneficial versus nuisance organisms.
All right. Next question regards birds. Can you be more specific as to research topics of interest for birds and bats, particularly with regard to impacts to migrating land birds and shore birds?
This was talked about a lot at the workshop on the East Coast about a month ago, that was looking at both seabirds, feeding birds, and land bird migration. A lot of the topics were looking at what data we have already, what we know about land birds who travel across the sea to get to South America, for instance, and how that was going to align with the wind farms. The discussion was really about how best to monitor this and what remote sensing techniques we could use, whether it was from satellites or whether it was from drones, whether we could use tagging, whether airplanes were the best method, and what coverage we needed to do that. And then really getting at how those data were processed to make sure that we were seeing genuine changes and incorporating everything. So the discussions about the actual research are still quite broad-based. It's looking at what are our baseline data, so what species do we have, what abundance do we have, what seasonality do we have, how do we monitor them? Do we use radar out at site? Do we still use people out at sites? Do we use cameras, or do we look at aerial photos, or are some migrations so large we can actually use satellite to get a better picture of what's there? And then what questions do we need to answer to actually determine what the change is? Do we look at the energetics, for instance, and actually look at the health of the different individuals that might be caught? So it's still a big area.
Question here is regarding entanglement. The question is whether PNNL, or I guess, or others, have looked at potential impacts of secondary entanglement for small marine mammals rather than our resident whale population.
We haven't. We'd love to. Excuse me. We've talked with Boehm more about how would you model, because the entanglement issue, okay, let me back up. The entanglement issue, I think as you saw from that video, is about scale. And the very large whales are simply, there's really just not a mechanism for wrapping those taut lines around them. And I would say that's even more true for the smaller ones. Now, if you're getting to smaller marine mammals, fish, turtles, that's where the issue's been raised about secondary entanglement from a whole lot of derelict fishing gear. We would love to do a little bit of modeling of that, because I think, again, you'd see quite quickly when you have these things quite far out at sea, you need to look at currents and so on, and where these fishing derelict nets and lines are likely to be. But I think you could make some guesstimates of what rate of sort of entanglement of fishing gear you might get, and from there perhaps do some projections. My take is with these offshore platforms, it'll be quite smaller rate, but no, we have not done that. Love to, be really fun, but.
I'm going to take a couple more questions here. I know it's now a couple minutes after time. A couple general questions here that I thought were interesting. How might one identify a sufficient scale of an offshore wind project to collect significant or relevant wildlife environmental data and information? And I suppose there's a sort of cumulative effects side of that question as well. I mean, how does one know when you've created a project large enough to actually affect the environment?
So let me
actually, oh, go on, Andrea.
I'll take one quick swat and give it to you. I think you have to parse it down, as we've tried to, into what part of the environment, and look at the relative risk. What is likely to reach some kind of critical level first? And that's why I implied with the oceanographic changes, probably you'd never get to those because no one would let you put in enough devices to change the ocean circulation. But I think you really have to parse it down. So Ginevra, what's your thoughts?
Fully agree. For different environmental factors, they'll be affected at different scales. So for a benthic environment, for that particular organism that's in that location, just one turbine will have an effect on that one organism. Whereas if you're looking at the migration of whales, you have to have a much larger area actually affected, much higher number of turbines. That also affects what area you monitor to start with in your baseline coverage. And a lot of that is informed by modeling from what we know now, as to try and determine, well, if we're looking at this scale, what are the potential effects? How far do we have to look at these to see that we're generally capturing any effects after the fact?
Last question here on, I guess, process. Because there are such different conditions on the separate coasts, is there some concentration on just what's possible or the effect in one place, like Oregon, for example?
I think obviously individual developers are looking at it as a smaller case because they're looking at their actual site. And Boehm has looked at it when looking at the various different lease areas in their local context. So that looks at it certainly at state levels. I think power, for instance, is you're also very aware of what kinds of developments are feasible within Oregon versus California. And so looking at different things differently. So I think that these regional entities are looking at the specifics for each state as well. I'm not aware of a specific Oregon community that is going out on its own, but you probably know more about that than I do.
Andrea, anything from you on that?
Oh, I was just going to say, I think that's exactly right, but let's not lose sight of the fact that the ocean doesn't know about state borders or even national borders, and we have to have these senses of, there's a lot to be learned from the overall processes of interactions, generally, wherever it's done, and then the need to look site specifically really comes down to what are the oceanographic processes there and what are the species that are there and habitats. So I don't think that it's going to be easy to say, this is the limit for Oregon, this is the limit for California. This is why having these coastal states look at this in a broad sense is really important. We're all California current here on the West Coast. So.
Okay, I want to be respectful of everyone's time today, and although we left a lot of questions unanswered, we need to go ahead and finish today. But I will note that in the future, we will be more thoughtful about how we might be able to address more of these questions. Perhaps we might create some sort of forum that allows us to answer these questions after the fact, because I did get a lot of good questions. And sorry if I didn't get to your question. And I'm going to hand it back to Matt now. I'm pretty sure he's going to note that we're going to be hosting some more of these, and we're looking for your input. So Matt, I'll just hand it back to you with that.
Great. Thanks, Jason. Thanks to all our speakers today. Thanks, everybody, for joining. If you have any burning questions, please send them to us, info@pacificoceanenergy.org. We're happy to route those questions to the professionals who could best answer them for you. If you'd like to present any topics of your own in future webinars, no promises, but we'll do our best to accommodate. So please feel free to email us with any suggestions there, and look for an email in the next several days with a link to a recording of this webinar, as well as we'll be sending out information about future webinars soon as well. So thank you, everybody, for joining. Hope you're well, hope you're safe, and look forward to seeing you in person soon. Bye.
Thanks, everyone. Bye.
Thank
Thanks,
you.
everybody.